Hello grade 12, you are now watching the last of the videos on the multiple choice section of the November 2021 paper 1 exam. We're looking at question number 1.7 to 1.10. Question 1.7 says two identical spheres P and Q carry charges positive Q and negative 2Q, respectively. Sphere P exerts an electrostatic force of magnitude F on sphere Q. So we can already write down that the force of P on Q is going to equal to F. Now they say which one of the following represents the magnitude of the electrostatic force exerted on sphere P by sphere Q. So they are asking what is the force of Q on P. They have half F, F, 2F, and 4F as options. Now, grade 12s, a lot of the time when we look at questions like this, we take them at face value and we decide, okay, this must be a question on electrostatics because they use the term electrostatic forces. But this is actually a question on Newton's laws. Specifically, it is about Newton's third law. And what does Newton's third law say? It says that the force that object 1 exerts on object 2 is going to be equal in magnitude but opposite in direction to the force that 2 exerts on 1. Therefore, grade 12, the force that sphere Q exerts on sphere P is going to be equal in magnitude to the force that P exerts on Q. And therefore, the correct option or the correct answer to this question is B. The force is going to equal to F. Now, if you don't believe me, I'd like to prove this to you mathematically, and perhaps this will help you to remember why the answer is like this when you write your exams at a later stage. To calculate the electrostatic force of P on Q, we say K multiplied by the charge on P multiplied by the charge on Q divided by the square of the distance between the charges. To calculate the force of Q on P, we're going to say K, Q of Q, Q of P, also divided by the square of the distance between the two charges or two spheres. If you look very carefully at the second formula, we can actually swap around the Q and P, and mathematically that is not going to make a difference. 2 times 3 is the same as 3 times 2. So therefore, this formula is exactly the same as this formula, and therefore, grade 12, these forces are equal in magnitude. Opposite in direction, but equal in magnitude, according to Newton's third law. Question number 1.8 says, in the circuit diagram below, all the resistors are identical. That means the resistance here, here, and there is exactly the same. Ignore the internal resistance of the cell. And on that note, we say, phew, because now we know that we are dealing with grade 10 and 11 work only. So grade 12, if we ask this question in grade 11, you should actually be able to answer it. If you are unable to answer this question, then you already know that there may be gaps in your grade 11 content knowledge, and therefore you should go back and fill in those gaps. Now the question reads, which voltmeter will have the highest reading when switch S is closed? Here we have a battery. We're going to close the switch, and the question is, does voltmeter 1, 2, 3, or 4 have the highest reading measured across it or measured by it? So which resistor or which resistor pair is going to have the highest voltmeter or give us the highest voltmeter reading? We remember all of the laws that come about when we learn about electric circuits. Let's start off by looking at this resistor. Can you see that this resistor is in series with the battery? What that means is that the total current is going to flow through this resistor. And therefore, if we would like to calculate the reading on voltmeter 1, we're going to say the resistance of the resistor multiplied by the total current. So it's going to be I total multiplied by R. Now, when the current moves, so remember, we normally deal with conventional current from the positive end of the battery to the negative, so current's going to move this way. When the current gets to this point, we know that the current is going to split. Since the resistors have the same resistance, half of the current will flow this way and the other half will flow that way. Therefore, grade 12s, the current flowing through this resistor is going to be half of the total current, and the current flowing through this resistor is also going to be half of the total current. If we would like to calculate the potential difference measured by voltmeter 2, we'd say V2 is equal to half of the total current multiplied by R. And this is equal to the reading on V3. V4 is the connection across this parallel connection. Therefore, V4 is also going to be half of the total current multiplied by R. So we're going to say this is equal to V4. When we look at what we've written down, we see that the largest reading is going to be measured by V1. And therefore, the correct answer to this question is A. There are many different methods that you can use to come about or come to this answer. But if your answer is correct, chances are that you're reasoning the correct way. We now move on to question number 1.9, which is, in which one of the following electrical machines is electrical energy converted to mechanical energy? Is it an AC generator, a DC generator, an AC dynamo, or a DC motor? Well, we know that in generators, energy, or rather mechanical energy, is going to be converted into electrical energy. So therefore, A and B are incorrect. Now, we don't often use the term dynamo in matric, but a dynamo is actually a generator, and therefore it has the same energy conversion as above, and we know that C is not the option. A motor, however, converts electrical energy into mechanical energy, and therefore the correct answer to question 1.9 is D. Question number 1.10 is the last question we will look at in this video, and it says, which one of the following combinations correctly links an emission spectrum and an absorption spectrum to the energy transitions of an electron in an atom? So here we're dealing with how an electron moves when it absorbs or loses energy. The wording here in the options is from low to high energy levels and from high to low energy levels. And I've included an image at the bottom to help us. This image is not given in your exam. So, the key word in absorption spectrum is the word absorption. What is being absorbed? Well, it is energy. Energy, most often in the form of light. An electron will absorb energy. And of course, if it absorbs energy, it's going to move from a lower energy level. Here we are looking at energy level 1. To a higher energy level, which here is energy level 2. If an electron absorbs energy, it's going to have more energy. Therefore, we know, if we look at the options for absorption spectrum, the correct option would be from low to high energy levels. And I'm going to highlight those. Now let's speak about the emission spectrum. The key word here is emission. To emit energy is to lose energy. So who or what is losing energy? Well, it is the electron. If the electron loses energy, then it is going to go from a higher energy level, like energy level 2, to a lower energy level 1. Since we know that B and D contain the correct option for the absorption spectrum, we're going to look at which one of those two options has the correct wording for an emission spectrum. Remember, if we are looking at an emission spectrum, it shows how an electron has lost energy, or it is as a result of an electron emitting or losing energy. So we therefore go from high to low energy levels, and you can see I've highlighted everything for option D because option D is the correct answer to this question. Grade 12s, we've reached the end of this set of videos on the multiple choice section of your November 2021 exam. In the next video, and those to follow that video, we're going to look at the longer questions, starting off with question number 2, which deals with Newton's laws. These are the laws that you learned in grade 11. So if you are finding that you just don't understand it very well, or perhaps you're even struggling in the section on work, energy, and power, and mechanics in general, then I want you to please pay careful attention to that video. I look forward to you joining me there. Thank you so much for joining me in these videos on the multiple choice section.